Good day, erudites! Welcome to Next Level Catch-Ups 2.0. This is General Chemistry 1 for your first semestral final terms. I'm Athena Arago, your lecturer for today's video. And in this video, we will be talking about oxidation and reduction reactions. But first, let's put down the basics and talk about oxidation numbers. So, oxidation numbers are small whole numbers which are related to the combining ratios of elements. This set of whole numbers are useful for predicting the formulas of the compounds, classifying them, comparing the chemical properties of the elements, and describing the chemical reactions. Why do we have to know how to find the oxidation numbers of certain elements or compounds? So basically, oxidation numbers help us know or determine the process of balancing the reactions. If we know the oxidation number of a certain element, we have knowledge on how to proceed with solving different kinds of reactions. Next, we have the rules and the relationship of oxidation numbers and the periodic table. So there is this relationship of the periodic table with the oxidation numbers wherein the metals have a positive oxidation number and they are equal to their group number. The groups are the vertical columns in the periodic table. So we have 8 groups in total. 1A, 2A, 3A, 4A until 8A. In nonmetals, they have a negative oxidation number, then they equal to the group number minus 8. Now, cations, they have a positive oxidation number. Since they are positive ions, then anions, they are the negative ions which have negative oxidation numbers. While the transition elements, they are the elements that have more than one oxidation number. Keep in mind that H+ is not a transition element. So we have a table for a clearer view on how to determine the oxidation number from the group number of the periodic table. For group 1A, the oxidation number is positive 1. Since ang mga nasa 1A to 4A, they are equal to the group number, ang oxidation number nila. Habang ang mga nasa 5A to 7A, sila yung mga nagsasubtract tayo ng 8. Kunwari, kukuha tayo from group 7A. So, we would do 7 minus 8 to get negative 1, which is the oxidation number ng mga nasa group 7A. Next is the set of rules for determining oxidation numbers of elements and compounds. For the first rule, we have uncombined elements. So the oxidation number of an uncombined element is always equal to 0. So we have sodium, magnesium, and hydrogen gas. They all equal to 0 kapag uncombined lang. Next naman is the order of elements or order of the oxidation number. The element with a positive oxidation number comes first in the formula, followed by the negative oxidation number. For example, we have sodium chloride, NaCl. So, ang oxidation number ni Na is positive while si Cl or chlorine is negative kasi yun nga ang rule na kailangan ang positive number or positive element ang mauuna palagi. For number 3, formula of a compound. In a formula of a compound, the sum of the oxidation numbers is equal to 0. So, for example, we have magnesium and bromine. So, oxidation number ni magnesium is positive 2, while si bromine may negative siya. Pero, dalawa ang molecules ni bromine, kaya we have to multiply by 2, so negative 2. So, if we combine positive 2 with negative 2, we get 0. So, this is the case kapag compounds, palagi siyang equal to 0. Next is for the monoatomic ions. In monoatomic ions, the oxidation number is always equal to its charge. Si Fe or iron, meron siyang positive 2 na charge. So, bale, ang magiging oxidation number is equal sa charge niya, which is positive 2. Lastly, for polyatomic ions, in polyatomic ions, the sum of oxidation numbers is equal to its charge. So, polyatomic ions, from the word poly meaning marami, naging combination na siya ng iba't ibang elements. So, we have SO4, negative 2. So, kunwari dito, ang hinahanap is yung oxidation number ni sulfur. So, yung charge niya is negative 2, which is magiging basis natin para makuha yung value ni oxidation number ni sulfur. So, since si oxygen, palaging negative 2 ang kanyang oxidation number, we have to multiply that with positive 4. So, we have negative 8. So, what will we combine with negative 8 to get negative 2, which is yung charge ng polyatomic ion? Positive 6. Oxidation number ni sulfur is positive 6. Let's move on to oxidation and reduction reactions. Let's first define what is oxidation and reduction, and what are their differences. Sa oxidation, this is the loss of electrons, while in reduction, this is the gaining of electrons. So, kapag oxidation, nawawala ng electrons yung isang element or compound. So, nagiging positive yung kanyang charge. Kunwari, from negative 2, naging 0 na lang siya. It means oxidation siya dahil naging neutralize yung charge niya kasi nga naging 0 siya. For reduction, dumadagdag ang electrons niya. Kunwari, from 0, naging negative 3, naging negative yung kanyang charge. It means dumagdag yung electrons kasi ang electrons sila yung may negative charge. So, ang redox naman, ito yung combination ni reduction at oxidation. And si redox, it happens simultaneously. Si reduction at si oxidation, nangyayari siya sabay. In the next clips, I will be solving a few examples of finding oxidation numbers as well as balancing redox equations or redox reactions for acid and basic solutions. So for the first 5 examples, we will be solving for the oxidation numbers of these compounds. So let's first tackle letter A. So we have H2SE. It is important to remember the set of rules in determining the oxidation numbers of the elements and the compounds. So as we can see, in this compound, its charge is always equal to 0. So here, we are looking for the oxidation number of selenium. So let's write down our equation. So 2, positive 2, plus x, since it is the unknown, equals 0. So now we are looking for a number that will satisfy this equation to make it equal to 0. This became positive 2 since hydrogen's oxidation number is positive 1 when we refer to the periodic table. So 1 times 2 is positive 2. Therefore, we are looking for selenium. So our x will be negative 2 since 2 minus 2 will equal to 0. Next, we have HClO3. So we are looking for the oxidation number of chlorine. So H is always 1. Its oxidation number is always 1. So positive 1 plus X. Then the oxidation number of oxygen is always equal to negative 2. So here, we have negative 2 times 3. It will give us negative 6. So it equals to 0. So now we have to find the number here to satisfy this equation. So we can say that x equals positive 5. So the oxidation number of chlorine is equal to positive 5, since 1 plus 5 minus 6 is equal to 0. Next, we have H2CO3. Now we are looking for the oxidation number of carbon. And we know that hydrogen has positive 1 charge and oxygen has a negative 2 charge. So here we have 1 times 2, positive 2, plus x minus 6, because negative 2 times 3 is negative 6, equal to 0. So now our oxidation number is equal to positive 4, since 2 plus 4 minus 6 is 0. Next, we have MgSO4. Now we are looking for the oxidation number of sulfur. So magnesium, it has a positive 2 charge. It has a positive 2 charge, and oxygen has negative 2 charge. So let's multiply positive 2 times 1 is 2, plus x, or the unknown, minus negative 2 times 4 is negative 8, equals 0. So now our x will equal to positive 6, since 2 plus 6 is 8, minus 8 is 0. So for our last example, we have CaMnO4. We're looking for the oxidation number of manganese. And for Ca, or calcium, it has positive 2 charge. And for oxygen, it has negative 2 charge. So let's multiply positive 2 times 1 is positive 2, plus x, minus negative 2 times 4 is negative 8, equals 0. Now our x, or the oxidation number of manganese, as we can see, it is positive 6, since 2 plus 6 is 8, minus 8 equals 0. So for the next set of examples, we have redox reactions in acid solutions. In redox reactions, we have two types of solutions, the acids and the bases. So we are first learning how to balance acid solutions, because in bases, there is one extra step in order to balance out basic solutions. So let's start off with number 1, bromine, Br minus plus MnO4 minus, then MnO2 plus BrO2 minus. So the first step in balancing redox reactions in acid solutions, we have to determine what is the oxidation and reduction in the equation, or in the reaction. In order for us to know, we have to group the elements accordingly with each other. So we have to group bromine and group manganese with each other. So let's write Br minus and BrO2 minus, and MnO4 minus, then MnO2. Next, we have to find the charges, or compute for the charges, to find out which is the oxidation and the reduction side. So we have negative 1, since we have a negative charge, and in elements, it is equal to its charge. So in the second compound, we have BrO2 minus. So we have to compute for the oxidation number of bromine. This compound equals to negative 1, since it has this negative charge. And we all know that oxygen has negative 2 charge. So negative 2 times 2 is negative 4. Now we're looking for bromine. So what should we add to negative 4 in order to get negative 1? So it is positive 3. So now we have negative 1 is to positive 3. So kita natin na lose siya ng electrons kasi naging positive na yung charge niya. So when we have the loss of electrons, it is what we call oxidation. So that means that manganese is the reduction part of the reaction. So let's solve for manganese. We have another compound that is equal to -1. So -2 times 4 is -8. And now we have to get manganese. So we have +7. Since +7 minus 8 is -1. Next, in MnO2, its charge is 0. So in oxygen, we have -2. So -2 times 4 is -4. And we have to find Mn. So it's +4. So here we have a loss or a gain of electrons since lumiit yung number niya. Naging +4 na siya. So it means that this is the reduction part of the reaction. Now that we know which is the oxidation and the reduction, we can write the half reactions. So let's start off with oxidation first. So Br minus and BrO2 minus. We have to balance out oxygen. So to balance oxygen, we have to add H2O to either side. So we can see this side has oxygen. So in this side, dito tayo maglalagay ng dalawang H2O since dalawa yung oxygen sa other side. So now that we have two H2O molecules, we have equal amounts of oxygen. But now we have to balance out hydrogen as well. So we have to add 2 times 2 is 4. So 4H plus. Now that we've balanced out hydrogen and oxygen, we have to balance the charges as well. So we have to add electrons to either side in order to balance their charges. So we have to find the charge for this side and the charge for this side. So on the left side of the reaction, we have 0 since H2O's charge is 0. Then bromine has -1. So we have -1. And on the right side, we have -1 and +4 since we have a charge of positive here times 4, which gives us +4. So we have +3. And we can see it has unequal charges. And we have to add electrons to this side in order to get -1. So how many electrons do we have to add to +3 to get -1? So we have to add 4 electrons. So 3 minus 4 is -1. So we have to add 4E minus. So this is the half reaction for oxidation. For reduction, we will do the same process. So let's write 1/2 reduction. So MnO4 minus and MnO2. Let's first balance out the oxygen. So alin nung mas malaking oxygen? Ito. So dito tayo maglalagay ng dalawang H2O. Now that we've balanced out oxygen, we have to balance out the hydrogen. So we have to add 4H plus. Then let's get the charges of both sides. So we have 4 plus. So we have +4 minus 1. We have +3. And for the right side, we have 0 and 0. We have 0. So we have to add 3 electrons in order for it to equal to 0. So 3e negative. We have completed writing the half equations for oxidation and reduction. Now we have to find the common multiple of our electrons to balance them out. So 4e and 3e. So ano ba ang common sa kanila? 12. So ano ang kailangan i-multiply kay 4 to get 12? We have 3. And for 3, we have 4. So now, ito yung mga i-multiply natin to balance yung charges. So 3 times 2H2O plus Br minus, then BrO2 minus plus 4H plus 4E minus. Same thing sa reduction. You have 4 times 3E minus plus 4H plus MnO4 minus. Then MnO2 plus 2H2O. Simplify. So 6H2O plus 3Br minus, and 3BrO2 minus plus 12H plus 12E minus. Then we can write ito sa ilalim nito para diretso na tayong combination after. So 12E minus plus 16H plus 4MnO4 minus, then 4MnO2 plus 8H2O. So we can combine both equations na. Pwede tayo mag-cancel ng mga like terms. So meron tayong H2O on both reactions. So 6 and 8. So 8 minus 6 is 2. So meron tayong 2H2O na lang. And sa 12 electrons, of course, cancel out na yan. And sa hydrogen naman, we have 12 and 16. So 16 minus 12 is 4H plus. So now we can write the final equation, which is 3Br minus plus 4H plus 4MnO4 minus. And then 3BrO2 minus plus 4MnO2 plus 2H2O. It is important to take note of the order of how you write the final answer, since that is also kailangan siyang i-consider. So, kailangan laging ang mauunang element or compound na ilalagay is yung from the oxidation or yung nasa taas. For number 2, you can pause the video and compare the answers. For number 2, you can pause the video and compare our answers at the end. So let's do the first step, which is grouping the elements and the compounds. So ReO4 minus Re, then IO minus and IO3 minus. Then compute for their charges. Re has -8, so +7. Then 0. So Re is reduction since it gained electrons. Next, you have IO. So iodine ang hinahanap natin na oxidation number. So negative 1. So -2, we have +1. So +1. Then sa second compound, we have -6. Then, positive 5 ang iodine. So, we have oxidation. So, we have to balance oxygen on both sides. We have 1 oxygen here and tatlo dito. So, dalawa na lang ang kulang natin. 2H2O. Then, we have 4 hydrogen. So, let's add 4H plus. Then, balance out their charges. We have -1 and then +4. So, we have to add 4 electrons to get -1. So, plus 4E. Reduction. We have ReO4 minus and Re. So, let's balance oxygen. We have 4 hydrogen, 4 H2O. So, let's balance hydrogen. So, 8H plus. So, let's get their charges. 8 plus -1. You have +7. And then 0 plus 0 is 0. So, you have to add 7 electrons to make it 0. So, 7E minus. Ngayon, we have to find a common multiple between 4 and 7, which is 28. So, you have to multiply oxidation. You have to multiply the oxidation side by 7, while for the reduction, we have to multiply by 4. So, let's simplify. 14H2O plus 7IO minus and 7IO3 minus 28H plus 28 electrons. Then for reduction, we have 28 electrons, 32 hydrogen plus 4 ReO4 minus 4 Re and 16 H2O. Now let's cancel out what we can cancel. First off is electrons. Then H2O, may matitirang dalawa. As well as hydrogen, may matitirang 4. Now we can write the final reaction. You have 7IO minus plus 4H plus 4 ReO4 minus. Then 4Re plus 2H2O. This is our final answer for number 2. Compare your answers if tama, and if you got the correct or the same answer, then good job. Now we have redox reactions in basic solutions. So sa basic solutions, it follows the same process in acidic solutions, but there is one extra step, which is the addition of OH negative in both sides. So it is done in order to balance out a basic solution. So let's first group the same elements. So Mn 2 plus, then MnO2, and Br2, Er minus. Let's get the electrical charge of, let's get the oxidation number of manganese. So in this element, we have a charge of +2, while dito we have 0 ang charge. So -4. So anong i-combine kay -4? +4. So here we have a loss of electrons. Since lumaki yung positive number, ito yung oxidation natin. Next, we have bromine. We have to balance bromine first. So Br2 is to 2 Br minus. Now let's get the oxidation number of Br. So Br is 0. And then 2Br, we have -1 here. So -1 times 2 is -2. So we have a gain of electrons, which is reduction. Now let's write the half equation for oxidation. You have Mn plus 2, then MnO2, then let's balance out oxygen, 2H2O, then balance out hydrogen, we have 4H plus. Let's balance their charges, 0 plus 2, we have plus 2, or positive 2, then 0 plus 4, we have, 0 plus 4 lang. We have positive 4. So, ano yung i-add natin? Dalawang electrons to get positive 2. So, 2e. And then next, we have half reaction of reduction. You have Br2 and 2Br minus. So you have a charge of 2, we have a charge of 0, and we have -2. So you have to add 2 electrons sa side na to para mag-balance out siya. Next. Ayun. So, we have the same amount of electrons on both sides. It means we do not have to multiply in order to get a same number of electrons on both equations. So we have to write na lang 2H2O plus Mn plus 2, then MnO2 plus 4H plus 2 electrons. Then sa reduction natin, we have 2E minus plus Br2. Then 2Br minus. Ayun. So, let's cancel out yung electrons natin since yun lang naman yung pwede nating i-cancel out. So, now we have 2H2O plus 2Mn plus 2 plus Br2, and then MnO2 plus 4H plus 2Br minus. Ngayon, ito yung extra step. Kailangan natin magdagdag ng OH negative sa 4H natin. So, ito lang naman yung may H plus. So, dito tayo magdadagdag 4 molecules of OH negative. Then, dito sa side na to, 4 OH negative. Since wala naman siyang katulad, kailangan natin ilagay sa space, yung space na walang katapat siya. So, kapag nag-react itong dalawa, magkakaroon tayo ng 4 H2O molecules. So, cancel out na to. So, 4H2O na siya. While dito is as is lang siya. So, the final answer we will have... Pwede pa natin i-cancel out pala si H2O. So, ang matitira is 2H2O. Ayan. So, ngayon, let's finally write our equation. So, 4OH minus plus 2Mn plus 2 and Br2. On the other side, we have MnO2 plus 2Br minus plus 2H2O. So, here's our final answer for number 1. Alright, that's it for today's lecture. I hope you learned something new from this video. Again, this is Athena and I'll see you in the next one.